Right, guys. Hang on, let me close this one. So, plan for today is to try and finish off those integrals, or at least as many of them as we can. Yeah, if you guys could put your names down, and I will take a quick register. So, all right. Joseph, why are you here? Because you're in the wrong group again. Are you here to? I thought you were here yesterday, though. This is just going to be the same lecture as yesterday. So, Ed, where are you? Ed. There, cool. Right, Ed sorted. Harry, yeah, I'll take you off for next lecture. That's fine. Emerald, Finn, I'll take you off for next lecture as well. Jack, Jasmine, and Sally, yeah, I'll take you off too. Grace, Elizabeth. Right, I'm missing quite a few of you. Dom, Rob, Jake, Jolie, Poppy, Molly, Melissa, Dan, and Ollie. Any of you there? If you are, comment later and I'll correct it later as well. Okay, so yeah, where did we get to? I think it's this one. I can't actually remember where you guys specifically got to. Oh, did I send out the email today? Maybe I forgot. Maybe that's why there's a few of you missing. Oh, wait a sec. Right, Jake. Yeah, cool. I'm just gonna send the link out, guys, because I think I forgot. It does take a while. Got to get the group, get the emails, copy, go to the email. Okay. Okay. Cool. All right. So, just gonna check where we got to last lecture. I think it was all these ones that are on the screen currently, but I'm just gonna have a quick look. So, yeah, so we got up to exactly these ones. Okay, so I set some of these for homework. To be honest, some of these questions are very difficult. So these are basically the further maths integrals that you can do with the methods that we have. Dan, cool, take you off as well. Done. Yeah, so if you did find these hard, then I completely understand. We're going to try working through some now. Yeah, we'll. I'm going to get stuck on some of these, I think, as well. Hey, Poppy. Poppy, tick. Cool. All right. So, first one then. Let's bring. Wait for the iPad, it's being a bit slow. Oh, cool, all right. So we're gonna move this screen up. So to do this integral, I don't know actually. I think it's gonna be some kind of double angle formulae. So if few ways we could do this. I think let's expand cos 2x. I know we got cos 2x, sine 2x. Ah, yeah, okay, that'll be it. So we need to spot that we've got double angle formula here. Melissa, I'll just swipe you in as well. Okay, so I'm going to rewrite this one as integral of 2 cos 2x to sine x cos x. So we've just broken that 4 up into two 2's. Now we're going to use a double angle formula on this bit to say it's integral of 2 cos 2x sine 2x. And that we can then use the double angle formula again to get integral of sine 4x. The sine integrates to minus cos, so we get minus a quarter cos 4x. Cool. All right, Ollie, I've ticked you off there as well. Okay, so that's the first one. Next one, cot x ln of sine x. And this is a recognition integral. And the trick to this one is spotting that cot differentiates to ln of sine x. So we've got a function, f of x times its derivative f dash of x there. And cot actually differentiates to minus ln sine x. We're going to need to tweak this one as well. So we're going to try cot squared x. So if we think about differentiating this, we'd get a 2 down the front. This is my test. 2 down the front, we get cot to the power 1. And then cot differentiates to minus ln. Wait, hang on, does it? Sine differentiates to cos. No, sorry, it is positive. To ln sine x. So all we need to do is half it. So we need a half chucked in there as well. And that is going to be my answer. Cool. All right. Any questions on those two? Those two weren't too bad. It does get a lot harder. All right. I'm going to give you guys some hints for these, and I'm going to let you try them because I would like to try and get through these with you guys doing it. So here we've got wow. I'll say here we've got recognition. This one we've got by parts. And think by parts again there. Next one we've got, oh god, what is that? I think no, that's not going to be by parts, that last one. I think for both of these we're going to have substitution, so maybe have u equals ln x all squared, and here we're going to have u equals ln x, and then you might need a second substitution, so you might say p equals ln u. Right, Rob, I've ticked you off as well. Okay, so could you guys try these three? The first one should be alright. Next two, quite a bit harder. All doable, but yeah, if you don't like substitution, you're going to find these challenging, to say the least. So if you guys could do these, I might give you 15 minutes or 5 minutes per question to work your way through these ones. And then we'll go through them. So 15 minutes starting from now. Right, scrap that for 16, guys. It's not a substitution, it's by parts. It looks weird, but yeah, you just do ignore what I said there. It's both bits by parts. Cool. All right. How did you guys find him? Yeah. Sorry about the second one. I thought it was. I read my notes wrong for that. So yeah, the horrible integrals. These ones. Oops. Just used a real pen on my iPad. So yeah, recognition for the first one. And the trick is recognizing that the bottom differentiates to the top. If you can't spot that, quickly we'll do the bottom. So integral of x ln x, we make u equal ln x. Dash is 1 over x. V, or dv by dx, is x, so v is x squared over 2. So the integral becomes x squared over 2. Wait, what am I talking about? No, we can't do this by recognition at all. We're going to have to use substitution again. Sorry guys, I gave you the wrong method for this one as well. What's going on with what I wrote down? Oh, that's the 12. Sorry. So yeah, this one by parts as well. So if we say u equals ln x for substitution, du by dx will be 1 over x. So dx will be x du. Just get rid of all this now. And that's going to turn into integral of 1 plus u over x xu. Instead of dx, we're going to put in x du. So the x on top will cancel with the x on the bottom to leave us with integral of 1 plus u over u du. So simplify that. So we're going to divide top and bottom by u. So we get integral of 1 over u plus 1 du, which turns into ln u plus u. Now u is ln x, so our answer is going to be ln of ln x plus ln x plus c. Cool. So that's the first one by substitution, not by recognition. Second one is by parts for all of this. So the first bit we'll have u is ln x, dv by dx is x, u dash is 1 over x, v is x squared over 2. So we get x squared over 2 ln x minus the integral of x over 2. So we get x squared over 2 ln x, take away x squared over 4. So that's the first part. The second part, we need to do another by parts on it. So we're going to have u is ln of x squared. dv by dx is again x. So du. We got chain rule here, so we're going to get 1 over x times 2 times by log x to the power 1. And v will again be x squared over 2. So we put it all together. uv be x squared over 2 log of x all squared minus the integral of v du dx. We see the 2's will cancel. The x's will cancel, leaving us with x ln x. And we know the integral of x ln x we did earlier on over here. So because it's take away the integral of x ln x, that's actually going to cancel. You can see this bit is here, and that's this. So we're going to get this again, but they're going to be subtracted. So our overall answer is just going to be this bit here. So answer x squared over 2 ln of x squared. All right. So I'm just going to write that down so I don't make the same mistake again tomorrow. So 15 was sub. 16 is by parts. 70 is sub. So yeah, 17 is the worst here because we've got to use substitution twice. So as I said, we're going to use u as ln x. So u dash is going to be 1 over x. Oh, let's write that differently. U is ln x, so du by dx is 1 over x. So dx is x du. So we're now going to convert the integral using all that stuff. So we're going to get on top ln of u over x times by u. Instead of dx, x du. So those two x's will cancel, leaving us with the integral ln u. And then I said use a second substitution, p equals ln u. So if p equals ln u, dp by du is 1 over u. So du u dp. So that will become the integral of p over u times u dp. The u's will cancel, leaving us with the integral p dp. P will integrate to give us p squared over 2 plus c. And we know p is ln u. So we're going to get ln u squared over 2. And we know u is ln x. So our final answer is going to be ln of ln x all squared over 2 plus c. So ln of ln x all squared over 2 plus c. Horrible integral, but yeah, that's how you do it. Right, has anybody got any questions about those? These would never come up on an A-level paper, but it's good practice and shows you some harder substitutions in case you're going off to uni to do anything maths related. Anyone got any questions about those? Ollie, no, is that no, you don't have any questions, or just no? They were hard. Yeah, that's true. They were hard. Cool. What's next? Okay, so these ones a little bit easier. So first one we got long division. Then we've got some partial fractions. I'm not sure about the last one. I was trying to see. I don't think it's going to be by parts because there's a lot of parts going on there. I think some kind of a substitution. That's a gut feeling. See what you guys do. Have a play around with it. Try a substitution. See if you can come up with one. I'll be really impressed if anyone can just do that with your own method. But I think it's probably a substitution just looking at it. So let's say another 15 minutes for those. And after that, we'll go through them and then we'll move on to something else the rest of the lecture. So 15 minutes starting now. All right. Yeah, these are horrible, as you guys have found out. So let's give it a go. The first two are okay. The last one is cruel. I didn't bother finishing it, so I'm gonna have to do it on the spot, but we'll see how that goes. So first one is long division. There are other ways to do this, but I think long division is the easiest way. So x squared, take 5x plus 6. What we're doing. The first, yeah, it looks like partial fractions, but obviously it can't be when you've just got one thing on the bottom. So because there's one term on the bottom, we can just divide. So x is into x squared, go x. Subtract those, minus 5 minus 5 minus 8 is going to be minus 13x. Drop down the 6. We get minus 13 up top. And what's that going to be? Yeah, 104, is it? Yeah, 104. So take 104. So we end up with minus 6, take minus 104 is going to be, wait, yeah, that's going to be 120. So we get x take 13 plus 120 over x plus 8. That's what we're trying to integrate. Okay, so the x is going to integrate to x squared over 2 minus 13x plus 120, then x plus 8, and that's it. We can simplify that. Plus c on the end, but yeah, there we go. You guys all right with that? Do watch, because I could be making mistakes here. I haven't actually done these questions before. So keep an eye on what I'm saying and writing. Second one is a partial fractions question. So and you can kind of tell because the denominator factorizes. So we're going to get a over, what's it going to be, x minus 3 plus b x minus 2. So we're going to get x plus 8 equals a x take 2 plus b x take 3. We'll say let x equal 2. So we'll get 10 equals minus b. So b is minus 10. Let x equal 3. We'll get 11 equals a. So a is 11, b is minus 10. So if we go back up to the top and write those in. And we get 11 ln, let's take 3, minus 10 ln x take 2. Cool. Yeah, there we go. Oh, okay. Next one is the horrible one. And there's two ways of doing this. I'm going to try it via substitution, like I said. It's probably going to take a whole page. But we'll see how we do. So, I said, well, I reckoned you could be ln 1 minus ln x. I think in retrospect, it's slightly easier if I just make u equal ln x. So I might change that. U is ln x. Okay, so du by dx is 1 over x. So dx is x du. Okay, so let's go through this changing all the bits. So u is ln x, so we're going to get u there. Then we're going to get 1 minus u. Then we're going to get dx, which is x du over x cubed. Now, one of those x's on top will cancel with one of the x's on the bottom. So we get u, 1 take u, du over x squared. So we just need to sort out the x squared. Now, if u equals log x, x is going to equal e to the u. So on the bottom there, that can be rewritten as e to the 2u du, which is now doable. It's not nice, but it is doable. So I'm going to get rid of everything apart from my u equals ln x at the top, because we're going to need that at the end to put it back in terms of x. And let's expand the top of this thing. So we're going to get u take u squared over e to the 2u du. Now I'm going to bring the e to the 2u up. So I'm going to turn it into two separate integrals. U e to the minus 2u minus u squared e to the minus 2u du. Now that's totally doable. The second one we're going to have to do by parts twice, but it is a possible integral. So let's, again, I need some space for this, so I'm going to write it one more time up here. U e to the minus 2u minus u squared e to the minus 2u du. Right, now I'm going to turn this into two separate integrals. So I'm going to make it integral of u e to the minus 2u minus the integral of u squared minus 2. And because I already did half of this earlier, I'm going to start with the second integral, just to save time. Obviously, if you're doing this for the first time, as I did just now, you just work your way through it. But we're going to start looking at that second integral on its own, and we're going to put it all together afterwards. So, to do that integral, confusingly, obviously we've got u, so I'm going to say u equals u squared, which is, a bit weird. U dash is going to be 2u. dv by dx, or v dash, let's call it to stick with the notation. V dash is e to the minus 2u. The v is going to be minus a half e to the minus 2u. So we're going to put it into the by parts formula, uv minus integral of v du dx, which will give us uv, u squared minus u squared over 2 e to the minus 2u minus the integral of v du dx, which will be plus the integral of u over 2 e to the minus 2u. Which is interesting because you can now see the bit in yellow that we just got is half of this integral. Cool. So yeah, I was hoping that would cancel, but I don't think. Oh wait, it'll get rid of half of it. Yeah. Okay. There's no point doing it twice though. So I'm going to write all this yellow bit where I've put the green bit here, because we've kind of done it. I've just spotted that we've got the same integral twice, so I'm going to simplify everything, and then we'll have one more integral to do. So this equation here is going to become what I write in blue. Integral of u e to the minus 2u minus the thing we just did. So that's going to be turned into plus u squared over 2 e to the minus 2u minus the integral of u over 2 e to the minus 2u. So we've got this bit here take away half of the same thing, we're going to be left with u squared over 2 e to the minus 2u. Take away half of the integral of u e to the minus 2u. So I've just simplified that. We're going to do this integral in green and then we're finished. So to do that, we'll have u equals u dash, of v dash even, equals e to the minus 2u. U dash is 1, v is minus a half, e to the minus 2u. So we get uv minus u over 2 e to the minus 2u minus the integral of v. So that's going to be plus e over 2 minus 2u. So we get minus u over 2 e to the minus 2u minus e to the minus 2u over 4. So that is going to be my answer. Those two bits plus the bit in green up here. So let's write that at the top up here, and then we've got some space for our answer. So we get integral equals u squared over 2 e to the minus 2u. Take a half of minus u over 2 e to the minus 2u minus e to the minus 2u over 4. That is my final integral, my final answer. So I'm going to simplify that, put x back in, and then we're finished. So I equals u squared over 2 e to the minus 2u plus u over 4 to the minus 2u plus e to the minus 2u over 8. Cool, none of that will simplify, so that is my answer. All I need to do is put ln x back in wherever it said u. And there'll probably be some log simplifying, so I'm going to write this up at the top to leave some space. So we're going to get ln of x all squared over 2 e to the minus 2 ln x, we'll sort that out in a minute, plus ln x over 4 e to the minus 2 lots of ln x plus e to the minus 2 lots of ln x over 8. Alright, so all those e to the minus 2 ln x's, they're all going to simplify. E and ln will cancel, but we first need to sort out the minus 2. So if we do, there's a few ways we could do this, to be honest. Let's say, let's bring the minus 2 up as a power. So e to the power ln of 1 over x squared. We'll do that for all of these. Cool, and we can go through simplifying those, cancelling the e's and the ln's out. So final answer time, we get ln of x squared over 2 times by 1 over x squared plus ln of x over 4 times by 1 over x squared plus 1 over 8 times 1 over squared. So we can actually factorize out the 1 over x squared. We could also take out a factor of, take a half out if we wanted to. Could take an eighth out if we wanted to as well, actually. Let's take a half out. 1 over 2x squared. And there is my answer. Yeah, pretty horrible. There is another way you can do it, but let's not bother. The other way you could do it is expand it all first. Real quick, just so I think the other way might have been quicker, actually. As soon as this loads, being a bit slow. There we go, cool. Nope, spoke too soon. Anyway, what topic would you guys like to revise next? We've got about 15-20 minutes left today, so I'd like to do something else. I was waiting for this to load. Cool. Yeah, there we go. Cool. All right, real quick, I'll talk you through this one and then we'll see what other topics people want to look at. So the other way to do this is to expand the brackets first. So we'd get ln x minus ln x all squared all over x cubed, which we could write as x to the minus 3 ln x minus x to the minus 3 ln of x all squared. We could then say that u equals ln x dv by dx is x to the minus 3. And in the other one, we could say u equals ln x all squared dv by dx x to the minus 3, and do it by parts. So we got time, we might as well do this. So u dash is 1 over x, v would be x to the minus 2 divided by minus 2. And over here, u dash would be 2 over x ln x, v would be x to the minus 2, same thing really, minus over 2. I need to remember it's one take away the other. So we could set up the by parts equations. So uv minus the integral of v du dx, which will be minus x to the minus 3 over 2. So that could become a plus there. And the other one, uv, so minus the integral of the 2's will cancel this time. And we'd get minus the minus 3 ln x. So again, we could turn that into a plus. We then need to do by parts again on this one. So again, it's that extra layer. So if we write these up at the top and do them again, remembering one has to subtract the other. Cool. So we get those two. We can make u. Well, in this case, we can just do the integral. So get minus 1 over 2x squared. Then x. Integral is going to go to minus 2. Divide by the new power. So that is the first part of the integral. The second one, and you can see if you look at the answer we're trying to get to up here, we got the quarter, we got the 1 over x squared there, the next term there over 2. So it's all kind of starting to take form. The other one then, if we integrate this one, we're going to need to do by parts again. So u is ln x, v dash is x to the minus 3, u dash is 1 over x, v is x to the minus 2 over 2. So that whole bit is going to go to 1 over 2 x squared ln x all squared plus the integral, plus uv. So that's going to be x to the, should be minus there, minus x to the minus 2 over 2 ln x minus the integral of v du dx, which will turn into positive, x to the minus 3 over 2. So one more time, if I write that at the top. So doing that last integral then, we will get, I need that minus sign still, in red, minus 1 over 2x squared ln x all squared, take 1 over 2x squared x. Integral this, x power is going to go up minus 2, minus there, all over 4. So that's the answer. Hopefully that will simplify to the thing I wrote at the top from the last question. If it doesn't, I might cry or give up. Probably just give up. So if we just try and simplify this, we need to do our signs and then kind of write it all neatly. So we're going to get minus ln x over 2x squared, take 1 over 4 x squared, take away. So the minus applies to the whole bracket, so the first term is going to go positive, plus ln of x all squared over 2x squared, plus ln x over 2x squared, plus 1 over 4 x squared. Okie dokie, so it looks like I've made a mistake. Oh my god, what have I done? Something's gone wrong, because half my terms are cancelling out. That's not good. So I make it that cancels with that cancels with that, leaving me with that, which is just that bit. Well, one of these is right, the other is wrong. I got a feeling the second one's right. I reckon in the first one I left out a whole term or a whole integral. Regardless, one of those is the right answer. I think I've made a sign error somewhere in one of these integrals, and it's either added or subtracted something incorrectly. I wonder what I did. But yeah, anyway, so that's how you do those. You can do by parts or substitution. Cool, all right. Yeah, I'll leave it there for today because you've got, what, 13 minutes left. Let's spend the next 10 minutes just going through what you guys want to do in tomorrow's lecture and Friday's lecture, and then after that is it 2 weeks left after this? Yeah, so we got basically 8 lectures left. Could you guys all comment? You got the second answer. Yeah, that's what I reckon is right as well. So it should cancel. I must have got a sign error in the first version I did. So yeah, 8 lectures left. What topics would you guys like to cover? I won't make them all that hard. That was just a really difficult integral worksheet that I couldn't resist trying on you guys. So what would you like to do in the last 8 lectures? We can do 8 topics. We could probably do more than 8 topics. Ollie says vectors. Okay. What else we got, guys? Proof. Okay. Okay, so stats, all right. I mean, given that the stat stuff is all videoed anyway, I might not do that because you can just rewatch the video. Because I feel like over the 3 classes, I did an alright job of going through that stuff. So, area between 2 curves. Oh yeah, I was going to do that today, wasn't I? Area between 2 curves and proof again. Proof would be good. Okay, so a few of you guys want proof, so I'll definitely plan something on proof. Yeah, just for stats, if you look back through if you look through my channel, look for all of the ones for your class, which is Group F. Like what dates? I don't know. Look at the titles. It's all in the titles. Modeling with sequences and series. Yeah. Any others, guys? That's 4 topics. They're not going to take 2 lectures each. Any others? Functions and trig. Okay. Any more? We can probably fit 2 more topics. Typical trig graphs. Yeah, like sec, cot, and cosec. I mean, I can go over them, but they are things that you can just Google. So I don't. Is it worth a lecture on them? Is all I'm thinking there, Elizabeth. If you just mean sec, cot, and cosec, they are just sketches. I can go over how you can derive them, but I mean, yeah, I can probably fit that quickly into the trig identities problems. Right, we'll start with that. What I'll do, I'll ask my other groups as well, and then I'll kind of come up with eight final lectures. Oh wait, there'll be less than 8. It'll be 7 because there's a bank holiday on Friday, isn't there? So it'll be 7. So that is 7 topics. Okay, I'll see if my other group are happy with those as well. Yeah, and we'll go from there basically. All right, cheers though, guys. I will speak to you tomorrow. Yeah, you can just use a calculator anyway, but it is nice to know how to drive them. I'll see if I can fit it in. It shouldn't take too long. Cool. All right. I'll speak to you guys tomorrow then. See you then. Cheers.